Hello and welcome to the Digital Health Hackers podcast. I have today with me two special guests, Daniel and Joost. Daniel, Joost, why don't you introduce yourselves?
Yeah, I'll start up. So I'm Daniel. I hail from Rotterdam, although originally from Indonesia, but that's a long time ago. I've been working in the data science field for over 25 years now. And the second part of that is mostly in healthcare. So I'm head over heels in healthcare. And I'm particularly focusing on the data interoperability and data architecture side of things, which is what we'll be discussing today.
Excellent. And Joost?
Yeah, thank you, Siddharth. So my name is Joost Holslag. I live in Arnhem in the Netherlands. I'm a medical doctor by background, just like you. And I spent most of my career on IT, which I really like. And I'm especially active as an independent medical informatics consultant focusing on data modeling and OpenAIR. So it's very nice to discuss this topic this morning.
Excellent, excellent. So, welcome all. And again, to give everyone some context about what we are going to discuss about, there was this almost landmark paper by the three big names from OMOP, OpenAIR, and FHIR, Converge or Collide, making sense of a plethora of open data standards in healthcare. And the conclusion here was almost you have these three standards: use OpenAIR for clinical care and administration, use FHIR for data exchange, use OMOP for longitudinal analysis. Now, Daniel disagrees. He's written a paper about the whole thing, like data interoperability in context, the importance of open source. So Daniel, what's your take here?
Yeah, so first of all, of course, it's nice to have the one-liner that I disagree. It's not definitely that black and white, because overall, I do agree that having a kind of archetypical application for each of these three open standards is a good starting point. And already the authors of the original paper argued that you need to look into open source to make sure that it's sustainable, etc. But we found that that paper was not specific enough, and that was triggered by my work working both in the Dutch context and particularly in the area of federated analytics and trying to build out a nationwide infrastructure for federated learning. That's one use case, which is called the Plug-in Healthcare project here in the Netherlands. And on the other hand, I've had the pleasure to work with Farm Access Foundation to roll out health information exchanges in Kenya. So this all happened in the past 3 years. And to my surprise, I did not expect that there will be so many similarities almost as to, what engineering decisions do you make if you indeed want to build, large scale production ready systems. And during those two projects, I increasingly converged into choosing FHIR over all of these three. And also in a way that does not one-on-one map to the original paper, because we're actually using FHIR in a very different way, using it to implement subsystems, or using FHIR more in a data warehousing context. And that led me to write this paper, by the way, not by myself but also with colleagues in the two projects. Also just to show, there's much more to be explored, and there are many, many more engineering and systems decisions that you need to make. And I was trying to combine those because I found myself even with seasoned data engineers. They were like, "What are you on about? This is never intended to be used that way." I'm like, "Yeah, it might not be intended to be used that way, but it works." And once we had it on paper and we actually presented it at some conferences, people were like, "Oh yeah, now it makes sense."
So Daniel, let's break it down, right? Like, so let's start with what you were trying to do, right? And like when you started deciding what exactly to use. Let's maybe break down the use case a bit more in depth.
Yeah, so I propose that we start then with the use case for health information exchanges in low and middle income countries, which is no, it's the other one. I think it's down in the paper. So if you could go to the diagram with OpenHIE, no, slightly up, more up, that one, yeah,
This one.
this one,
All right.
yeah, that diagram. Yeah, so OpenHIE, so HIE is Health Information Exchanges. I've looked into HIE platforms for quite a while. I went to the HIMSS in 2014, I recall, and everyone was talking about HIEs, but it was still quite difficult to implement all the different subcomponents. So basically taking it from the bottom to the top, you have the point of service, the system of records at a clinic, at a pharmacist, at a community health worker. You want to kind of integrate all of those. And basically the OpenHIE says, and OpenHIE is the open source implementation of that, is we need some kind of interoperability layer with mappings and interlinking services. And on top of that, we can build registry services, sometimes also referred to as common services. We need to have a vocabulary. We need to have a health worker registry. We need to have a client registry. And then on top of that, you have the business domain apps. You want to use all this data for logistics or for financial monitoring, etc. So this is all fine and good. I think most people who listen to this podcast can recognize this. And our challenge was, how are we going to build this in Kenya and Tanzania, where the actual healthcare facilities often are very resource constrained. They don't not even have a desktop, let alone a server. And how can we make it as simple as possible that all these components can really be, built out one by one rather than with one large big bang, with one monolith requiring a lot of resources. And I was surprised to find, or because I just didn't know, it was the first time that I worked in the African context, that FHIR is, quite active there. There are quite a few healthcare startups using FHIR as the common, building blocks through which they were actually implementing these things one by one. So that led me to believe, how could we build on that? Because again, it's so resource constrained. We can only build one interface. And in this case, it would be the FHIR interface.
So let's talk about this a little bit more in depth, right? Like, so, okay, you have these different point of service applications.
Yeah.
Now you needed to build all of this in Kenya for the entire system. Yeah. So where exactly did you notice the usage of FHIR with these startups? Like, was it was it one provider with a medical record who offered FHIR as an integration layer? How exactly was FHIR being used?
So what I've seen happening, and that's particularly also the work of ONA. Matt Burke is the founder of ONA, so he's one of the co-authors. What you see is that typically it's at the end of the day, it's just FHIR apps. So in the Western context, we have this framework called Smart on FHIR, where FHIR is in fact the backend database for any app that you want to build. ONA have built an open source alternative of that as well, which is the other diagram down. So what we saw is that in fact the apps further down, the other this one, OpenSRP framework. So this was actually being used in the field. For example, there was a midwife app that is operational in Indonesia. The midwife registers all her activities in the app. That gets pushed to FHIR messages, and it's being pushed into one of the core components of OpenHIE is a shared health record, which is a HAPI FHIR server. That got me thinking, there is a workable solution end-to-end, which is currently operational, albeit often still in a kind of evaluation context, but I could see this happening. And typically also to give a sense of the scale and scope, the OpenHIE specification is designed to have a scale of typically a province or a county in Kenya or Tanzania. We're talking millions of people, not hundreds of millions. We're talking about hundreds of healthcare facilities. So it's doable. And it's doable with relatively cheap technology and resources. So that was for me a big step up towards, okay, if we take this and force ourselves to be economical about what we use, then it can work in this case, in the Kenyan and Tanzanian context. And later on, I said, but if we have this, there are many smaller healthcare facilities in the Netherlands as well, GPs, for example, and perhaps we can transplant it there. That's kind of how it played out. So this is all after the fact. I didn't plan this. It happened.
Got it. So the lesson here is again like you have people who are already building FHIR apps in
Yeah.
Tanzania and Kenya. They know how to do this. They're already starting to build all of
Yeah.
this. So you just take it like, okay, this is what people are doing already. You already have
Yeah.
a bunch of SDKs. I think this one was by Google, the Open Health
Yeah.
Stack, and
Yeah.
you have the HAPI FHIR server. Just put them all together and in your opinion, so does this just propagate throughout the whole layer? So then because this is FHIR, now this also becomes FHIR, and then this also
Yeah.
becomes FHIR.
And that's in fact one of the points made in the discussion, one of the closing comments. So in the context of resource constrained environments like Kenya and Tanzania, FHIR is used for all three. For the system of record, for the original data capture, and it's used as an exchange format, and in fact it's used as the data warehousing format because it's called the FHIR data pipelines.
Right.
So one of the principles is that the transactional system is the shared health record, and indeed it's that diagram with the purple blocks. If you go one up, so that one. So on the bottom right-hand side, which is also something that ONA built, they built data warehouses for the UN, for refugee camps and things like that to monitor those areas. And it's all open source data warehousing technology. So you see that FHIR propagates throughout, and it works. It works to reasonably large scale, I would say.
So excellent. I think we've come to the exact same thing. Like, okay, this doesn't first of all work in, let's say, low resource environments where, again, if somebody is already building something on FHIR, it's just easier to keep using FHIR for all three instead of like building expensive mapping between the standards. Now, I think Joost has been a little silent. I know Joost is a big evangelist of OpenAIR. Now, how does this make you feel, Joost?
Yeah, well, first of all, I was really impressed by the paper. It's as Daniel said, it's quite a novel topic. There's not a lot of consensus or experience on how to set this up in this scale. So it's really helpful to have this discussion. But also what I see is a lot is that we just scratch the surface of complexity of the challenge we're talking about. And when I hear Daniel saying FHIR is used throughout, so at three levels. One of the challenges with FHIR is that it's very easy to adopt and thus applied in different ways. So one of the first questions I would have, if Daniel describes it this way, how much does the FHIR resource change between the three applications of FHIR? Because my assumption, you need a different profile for the exchange versus the initial capture. And then you have semantic differences between those scenarios. And then you're back again at the big challenge. How do you map semantic differences? And then, FHIR doesn't solve that for you. It's just a vehicle for sharing data if you get agreement on the semantic differences or on the semantics.
No, so that's absolutely a fair point. And in fact, we had these discussions within the project team, and we haven't completely solved it, because what happened during the project is we just quote unquote used the base FHIR definitions. So FHIR R4. We did not even use any explicit profile. And if we made a profile, it was just for practical reasons. We did not add that many constraints or that many coding systems, because we found that the incoming data was of such a complexity that is low complexity. It was all just too much overhead. So the main use case was maternal and childcare. So we were talking about questionnaires, about getting the context, the usual questions when you do an intake for a pregnant mother in these countries. And at most, the one thing that was the most difficult is that we wanted to have unified coding systems in ICD-10 for the comorbidities of the pregnant mother. And indeed, you are right. So I thought, oh yeah, there's loads of work on maternal care internationally. So I've looked into the WHO antenatal care profile in different countries, and that's where you get down the rabbit hole. But we actually kind of we postponed that. We kind of said we deferred that issue down the line because it wasn't really that necessary during the project, because we had another challenge. The apps that we were working with had not yet implemented a FHIR facade or a FHIR interface. So we were still, one step before making sure that the partners that we were working with actually moved into this. So I said earlier, I have seen people using apps already in the field. Of course, those are the leading parties or projects. And the people that we were working with, we still had to onboard them and do the transformations. I kid you not, I wrote those transformations myself. It was MySQL Server version 4, and I hard-coded it in MySQL, and I just ran a FHIR v4 based validator, and that was the end of it.
So could you share a little bit more about the clinical use case, Daniel? Because what's mostly consensus is that FHIR resources are quite well modeled for administrative and demographic information, like the patient, appointments, practitioner, this stuff. But when it gets down to clinical, there's actually very, very little modeling done in the FHIR base resources. The only normative resource is observation, which is super generic. So I wonder how much clinical depth did you reach in modeling? Because maternity care can get complicated modeling-wise very quickly if you start to do pregnancies, ultrasounds, medication. It easily gets complicated. So where did you end up in this?
So we used the FHIR resource condition to register comorbidities. So typically in the African context, does the pregnant mother have a history of malaria, or does she have a history of HIV? Those are two ICD-10 codes. And we really just focused on making sure, what's the short and limitative list of comorbidity conditions, and that we actually hard-coded, made sure that that's actually translated into ICD-10 codes. And the same holds for observation. So I think I forgot the names. You're the doctor. They're very simple tests that you do when a young mother presents itself, or pregnant mother, what you do in the first and second and third term. Again, we kind of looked up those codes using the WHO standards. And all in all, it was something like of order 100 codes that we needed to extract from the source systems, which were not enforced at entry. So that was just kind of the workaround that we kind of hacked our way through. But because it's a short list, I mean, it's only just a kind of 100 codes that we needed to transform, that was doable. But you're absolutely right. Once the use case gets more advanced, then you need to enforce far more clinical rules.
So I'm going to be the devil's advocate here, Daniel. So I think Joost is arguing like, okay, why there are different versions of FHIR that we've been using throughout. And as you're transitioning between the three paradigms, you're sort of changing this data model. Now, my question here is, okay, like we've done all of this. There is a HAPI FHIR server. There is all of this ClickHouse and all of the ETL Kafka. We're doing all of this. But why really use FHIR at all? Like, why not? So if they're inventing this whole use case and we know that they want to capture a condition, or we know that they want to capture like an observation, you could as well just model this as like normal SQL tables or like JSON in a normal database. Like again, HAPI FHIR also comes with a lot of baggage, right? So why not just build your own data models? Why did you choose something like FHIR?
We did not have the time and resources. It's as simple as that. I mean, for example, I've had a serious look at OpenMRS, which is one of the larger open source EHR systems. I've looked into the data model at length. There are many forks of OpenMRS, but I'm like, it's for the reasons that we mentioned in the paper, I could not see how this would work out in practice, within the time frame of the project I was working on. I just could not see it working. And again, it's perhaps important to note that I come from the background of secondary data reuse, whereas Joost in his work is more involved in the primary, how do we make sure that the data gets entered properly in the first place? And since I'm focusing on secondary reuse, my position or the way I approach it is like data presents itself to me and I have little influence about how it's being recorded, etc. And of course, I would like to have it, better at the start, because that saves us a lot of effort from wrangling it in the right direction downstream. But I don't have that. I can't intervene on that level.
Yeah.
So
Yeah, I think this is the key difference between Daniel and me. And I think this also reflects the different design perspectives of OpenAIR and FHIR, where FHIR takes as a given that you can't control the source data and you know it's messy, so you want to exchange it anyway. So FHIR gives you a lot of great tools in order to do that. And OpenAIR is saying no, that's not the way to solve it. You never really can solve it that way. So you have to intervene at the source level. You have to specify how to enter the data. And we just accept as an OpenAIR community that this is a decades long endeavor and that it goes slowly. But as a quote from one of the founders of OpenAIR, it does go only one way. It does go forward. The OpenAIR movement never goes backwards, but yes, it goes very, very slowly. So apparently we are doing something right. But yeah, it's a huge endeavor, and it makes a lot of sense that both perspectives exist because they can complement each other.
Yeah, no, I'm actually like super interested in the discussion around. So this is a new. It's almost a greenfield project, right? So when you had to like build all of these different systems, Daniel, it's a greenfield. You have the choice of you can throw anything at people and they would sort of comply, right? So you did not have a pre-existing framework of interoperability, nothing. It's a completely greenfield setting. Yeah.
Yeah. For the purpose of this discussion, it was mostly that. Of course, in real life, it's not black and white, because if my pharmaxis colleagues are listening in, they would just choke in their coffee, so to speak. But yes, for the sake of discussion, it was more that than the other.
Understood. And here, you just were able to get started with the FHIR data models faster. People just understood what to do. Like you saw the observation resource, you saw the condition resource, and you're like, okay, cool, I get it. Yeah. And I think, let's carry on, right? So you are able to capture data at the point of point of service through FHIR, mainly because it's easy, you're able to put this all in. And here, how is this architected exactly? Like, are all the apps sort of writing to one single central FHIR server?
Yes. So to me, one of the key points is this shared health record. And in fact, I joined in a number of technical working group community discussions with an OpenHIE community. But there I also observed that there is a kind of the misunderstanding about what that central FHIR HAPI server exactly is. There's a lot of confusion, and the specification actually says that HAPI FHIR server, that shared health record, is a transactional system. It is not the data warehouse, quote unquote, of, for example, a county or a region on top of which you do secondary data reuse. But that kept mixing up all the time. And I actually put out a discussion in the community saying, look, guys, we need to be more specific about this. It needs to be separated because otherwise we keep confusing one another. Because that HAPI FHIR server serves as a backend for whatever app, be it a midwife app or a community health worker app. But of course, if you do bulk analysis in a kind of data warehouse pattern, which is here shown on the right bottom hand side, yes, you can use SQL-on-FHIR. You can build that, and you can quite quickly build data warehouses. Today, I would say, if you want to use OMOP for that, it's almost as easy as what we've built, but the FHIR to OMOP translations were not available at the time. They now are. And going back to the discussion between primary and secondary, the shared health record to me is a transactional system. If I would follow the reasoning of the original authors, I would say, yeah, that SHR could well be an openEHR server. And when the FHIR to openEHR mapping and standard is mature enough, it would be a swap out replacement. I could see that happening. But at the time when we were building this, that was not an option. So the good news is, and indeed I do believe that by thinking about this way, and I also see that these feuds, if you will, between the three communities and the three standards, I think we have to thank the original authors of the original paper that they really said, oh, guys, we need to get our act together. And we need to start thinking about composable systems and making sure that these mappings start working. So I do believe that there's more to be had in the long run to make sure that it converges. And thank goodness we are seeing that convergence. But building it out in real world systems and knowing what the clock cycles are of these systems, we need to keep at it.
And Daniel, if you were describing resource constraints for the low and middle income countries case as a key reason for doing only FHIR. But could you explain a little bit more, because you describe open source is a huge pro for financial constraints, I assume. But also for openEHR and OMOP, there are open source implementations. So where exactly is the resource constraint in using the three different technologies versus FHIR everywhere?
It's more a matter of that you need to form a development team or Scrum team, whatever you want to call it, that needs to cover so many technologies and components that it becomes even more challenging. And also just to, what I've seen is, although people are embracing FHIR in these contexts, I was actually discussing this project with a university in Nairobi, one of the leading universities. And I asked them just to get a feel about the context that I was operating in. How many clinical informaticians do we have? How many data engineers do we have? And how many of those have ever worked with FHIR? Well, you can kind of guess what the answers were. We need to, you need to bring together so...
What were the answers exactly? Like, did nobody have experience, or did people know?
No. Clinical informatics is very, very scarce, at least in the Kenyan context, what I've seen. Very scarce. I actually gave my first guest lecture for 70 data engineers online 2 years ago. It was amazing to do, but also to see that they were not aware. Wow, hang on. We have all these open source data engineering components. We didn't know.
This is so I think that's why open source and having someone already have, like, they've done this for you, and in your case there was the health stack, it's done.
Yeah, and Daniel, in the paper it's written that the lower complexity and shallower learning curve of FHIR compared to openEHR. Maybe you can find the statement, Siddharth. The shallower learning curve. And I wanted to learn your experience, because I think there's consensus that FHIR is easier to get started with. So I can see that if you're in an environment with resource constraints in a number of experts, of specialists, that this is an advantage. And it's a big advantage of FHIR in general. But in my experience, FHIR is not less complex. It's just that the complexity is deferred. It's possible to do simple use cases much simpler than with OpenAIR, but you ignore most of the complexity that's there, and you do it at your own risk and cost. So you build up legacy, technical debt, semantic debt, if that's a term. And also you don't realize, for a developer, it's quite hard to realize the clinical safety implications of making a mapping or a FHIR implementation decision. So is there any experience with this in the project?
You're absolutely right. So I fully concede this counterpoint. And it's very tangible as well. Many of these countries lack a nationally vetted profile, which is the very least what you need to do. I know India has one, particularly also in the reimbursement area. Kenya or Tanzania have none of that. And indeed, the way I positioned the work that we do at Farm Access, we were really trying to show to the people, this can work, but it's just the first step up towards a paradigm change. And indeed, the whole governance and political discussions to move towards a properly governed, nationally vetted FHIR profile. That's deferred. That's still a lot of work that needs to be done. You're absolutely right.
Yeah.
But
So
at least
how do
go
you
ahead.
handle this in the project? Because there's clinical safety risk. So if you make a wrong decision, it will impact the lives of real people, as an engineer. So somebody needs to take responsibility for making that decision. And I'm curious whether the governance structures to make those decisions are in place in lower middle income countries. Um, can you say a little bit about that?
Yeah, so the way it worked, so imagine that I, together with my colleague, Chris is his name, he was the lead data engineer in our Kenyan office. We literally wrote code, and the key parts which involve, for example, the clinical mappings, we discussed that with doctors locally. And knowing that the data is messy, because in the systems we saw, oh, is this actually an HIV comorbidity, or is it actually something else because it was ambiguous? And that was one of the more crucial clinical interpretation steps, if you will. But on the other side, the whole mom care project from Farm Access has very simple goals. So, for example, it was proven over and over again, if we could help often young pregnant mothers to visit the clinic 4 times during the pregnancy, that reduces child and maternal mortality considerably. So we're not even near very detailed clinical models. We were just doing the logistical part. Where have they been seen? Integrating. Oh yeah, but her first visit was at this site, but the second one was at that site. They did not know of one another. So that's actually where we focused most on, to reconstruct just the logistical, if you will, journey, because that already provided enough data for an intervention. In this case, just to make sure to get the bare basics right. Make sure that these pregnant mothers visit the clinic 4 times. And that's the end of it. So again, the context is quite different from what we work here in the Netherlands. It's not that, yeah, it's not that much clinical knowledge that was our key challenge.
So Daniel, I have a quick question for you. So what, I think you mentioned the Open Health Stack, the Android FHIR SDK, there is the HAPI FHIR server. And is it fair to say that if these libraries weren't as widely available, and again, I think the Open Health Stack came about a few years ago. It's quite a recent release.
It's quite new, yeah.
Yeah, so if this wasn't available, what would you have? Would you have thought differently? Would you have chosen something else?
So if I do a thought experiment, so I time travel 3 years back, and all of this was not available, and again, my assignment at Farm Access is secondary use. And I look around and see, oh yeah, there's still a lot of legacy systems, including the apps that Farm Access had built out over the years, whilst developing the mom care concept. What I probably would have done is I would have used OMOP because it's so simple. I would just spin up a simple database using the OMOP, and it's then schema on right, and that will be the end of it. But it's not, because then I would at least have a standardized data model to support the analytical questions that mom care had.
Quite interesting.
The TUFA project.
Yeah,
I had never heard of this.
Yeah, okay. So it's very interesting because they have kind of fallen into the same sort of thing. And I think in their manifesto, they write deeply about like, okay, why didn't you just choose OMOP? And then like, why didn't you build on top of it? Right. So I think this whole project is basically taking data from multiple different things and then like making a dimensional data model, then making it ready for like, there are these different data marts for analytics and so on. But Daniel, I think a lot of what you say makes sense in the context that you were, right? Like, so you had all of these tools ready to go. You had the data models ready to go. You could just understand the use case. You could teach developers to easily use something like FHIR. And it didn't take them. And again, like, did any of the developers who built these applications with you, or did they already have any FHIR experience, or were they completely new to FHIR?
So in the case, I've never been to Tanzania, so I've been to Kenya twice. Luckily, there's quite an active startup and technical community in Kenya. There is literally one shared office space where a lot of the health tech companies are, and in that building, there were enough people with hands-on experience in building these systems. These are actually the local partners that we engage. And I thought, like, yeah. From the very simple principle, we want to engage local partners as much as possible. I said, yeah, well, that's it then. We're just going to use FHIR because at least we have FHIR indication.
Okay, they had FHIR experience.
Yeah, but it's literally, I could pinpoint the building in Nairobi where I found enough people to click these things together. Yeah.
Excellent. Okay. No, that's super cool. And I think let's come back here, right? Like, so I have a few more technical questions, right? So again, HAPI FHIR, I think you talked about this being the transactional record and this being the analytical record. Where exactly did people get confused in terms of like, okay, can we use this for warehousing purposes? Like, why did they want to use HAPI FHIR for warehousing? Exactly. Like, what was the use case?
So oftentimes what happens is typically in a political and say policy environment. It's good to mention that Kenya in fact has a decentralized governance structure because each county is relatively autonomous to make their own decisions. So we would often, as a development organization, get the question, okay, please help County XYZ to make the first steps into having an HIE for their county. And of course, these people have less technical experience than we do, and then they read the newspapers that go like, oh yeah, we want to have a data and AI platform for County XYZ, and that's just not specific enough. So you need to break it down. And on the one hand, the policymakers, they have a need to have dashboards or monitoring, which is secondary data reuse. But on the other hand, we really believe, look, you need to have a shared health record registry because there's many small healthcare providers, and making sure that they have the same information is a big step forward. And that's a transactional system. I need some kind of central server. If a patient represents myself, that at least I know where have you been in the past 6 months. And also that transparency is also crucial in making, in a step towards making sure that the healthcare system at large in those countries becomes more robust, becomes more transparent, and becomes more efficient. So there's loads of, systemic, also dynamics, which which from which I think that of having such a shared health record is key. You can't do without almost. I can't imagine how you would, push the needle ever so slightly in the right direction in these countries if you don't have this. I can't see it.
Oh, absolutely. It makes a lot of sense. But here, I think I've run into a few issues with, I think Catalonia is right now implementing an open-air shared care platform for the whole region. So what happens usually is in healthcare specifically, there is this gray zone between what counts as transactional and what counts as analytical workloads. So I'll give you an example. So I think it's common for a doctor to ask, show me all patients who have a particular diagnosis, right? Or like, show me all patients who are yet to come do this procedure. Now,
Which
in a traditional...
on my ward have a fever.
Yeah, Joost?
I was giving another example. Which patients on my ward have a fever or a high pulse rate? It's a very simple question for a doctor, but technically it's quite challenging for a transactional system, right?
Yeah, I think the ward is still manageable because I think the way that this is laid out is, and I'm assuming this HAPI SHR server again was running on top of something like Postgres, as traditional like robust RDBMS.
Yeah.
So I think what happens here is that it's not tuned to handle population level queries, right? Even if you say, okay, I want to know who is the people in my ward who have this disease, or like show me all the diseases that my patients in this small subset have, like you're still scanning maybe at max like 100 rows, right? Like those are the patients that you need to worry about. But I have seen in like actual scenarios where we are implementing population level systems, and then the doctor or like someone at the government wants to see, okay, I just need an encounter list, or I need a list of people who have not come back for a particular procedure. And that becomes, that's literally like you gotta scan through your whole population, find out all of the things. And this is a very typical columnar workload. Like usually it's an analytical workload. You want to do it on something like, again, ClickHouse is an excellent choice. There are hundreds of these columnar databases out there. So I'm wondering, Daniel, was there a point where they were like, hey, this FHIR search query is taking too long. We want to find out something, but like we are not able to use this shared health record. So was there a point where you started pushing the needle and like you started saying, oh, that is not meant to be done on a transactional system. You have to do it on ClickHouse?
Yeah, that's actually from the very outset we took that route, because I can't even recall how I got there, but quite early on, I got involved in the SQL-on-FHIR working group. I haven't done any of the coding. I just contributed in terms of the use case that I just explained. And I thought, oh yeah, so we have the bulk FHIR interface where you could have bulk FHIR in NDJSON. And again, I come from a data engineering background. So I'm going all out on columnar stores, on serverless from the data engineering community. And that's why I also could see it happening, tying all those technologies, which are now so mature and performant. In fact, in the real world, we actually turned off the FHIR server, the HAPI SHR server, once we actually deployed it. Because for our use case, we were just doing it for secondary data reuse, and kind of the ecosystem that we're trying to to make grow. It took a long time before we actually onboarded more clinics. So after a couple of months, we actually turned it off. But the whole principle was still there. So we just had some kind of blob storage with bulk FHIR, and that's where we kept working with. And the way I see it is, once this ecosystem is in place, the shared health record would be there. It would be operational. It could support messaging between individual facilities. And I'm assuming that it has a bulk FHIR interface, on top of which we use now the SQL-on-FHIR stack to lessen the load for this data warehousing pipeline. So that, to me, was an end-to-end solution. And again, going forward, I would love to see that pattern could evolve. So let's imagine that the shared health record is an openEHR. What would be the bulk interface for openEHR? And does the existing query language of OpenHIE, does that support the same mechanism? That we lessen the load and the hurdle towards secondary use in a kind of data warehousing pattern. And if the answer is yes, then I'm like, yeah, it's the same solution pattern. And over time, we can swap out the actual implementations depending on the context.
Well, to answer your question, and maybe Siddharth can pitch in, but basically yes, and more. OpenHIE offers a very generic bulk query language that's both a great fit for getting specific patients' data. Patient X, give me the recent blood pressures, or any patients with a diagnosis of diabetes, give me their medications for 2022 to 2024. You can do all that. And on the other hand, we were talking about performance, like doing analytical queries on a transactional system. And the challenge is basically the same, I would say, between FHIR and OpenHIE in this respect, at least technical performance-wise, because both are basically or practically JSON blobs of data, and you have to query through the different JSON blobs, and that's just hard computationally, especially if you start chaining parameters to filter on. So I would say the OpenHIE systems, the clinical data repositories usually have more optimizations for specific queries because they are built as a transactional system instead of a system for exchange. But it would be a huge opportunity for collaboration, in my opinion, because the challenge is so similar. It's just a waste of energy to do this totally separately between the FHIR and OpenHIE community. What do you think, Siddharth?
No, absolutely. I've heard this so many times that at the end of the day, everyone, both the OpenHIE community and the FHIR community, they're throwing JSON-B in a database, mostly Postgres. It's like 99.9% of the time Postgres, and they're doing all of the queries on JSON-B. Okay, and I just I've dug as deep as possible into this. There are just like limitations when it comes to the page size and exactly what kind of performance that it can give. I don't know, honestly, like, is this the best way that we as a community have decided to do transactional health systems, right? Like, so my opinion here, at least, again, it's been in the making, like I've been thinking about this a lot, but I think at the end of the day, what FHIR really gives us, and again, even Daniel has agreed to this, is it gave him a data model to immediately start off with. It gave him and his team an ecosystem of different tools to take and use. Somebody had experience like already working with FHIR and like actually using it. So they were able to quickly get started and like build these real use cases that made a difference in the workflow, right? So I would say if OpenHIE gets a few more years, right, like maybe another 3 years, 4 years, the ecosystem would be similar. Like it would probably be, and again, FHIR also has the unfair advantage of the US government pouring millions of dollars into it. But OpenHIE,
That's right. The advantage is over, isn't it?
right now, yeah, I think they've cut the funding, but doesn't mean, but I think it's in legislature, right? Like it's already a regulation. People are.
It's mandated.
So
that's one of our arguments. It's
Is it still?
Yeah, Joost?
Is it still?
I think it is still mandated, and in fact, I think it's also mandated in India. With the HCX protocol for reimbursements.
Around the world, I think India has 2 protocols on FHIR. There is the ABDM, which is for just health exchange, like the data exchange, and then the NHCX, which is like the insurance exchange. Very
exactly.
Similar.
Yeah, I've looked into that one. Yeah. Mm-hmm.
Yeah. Saudi Arabia has something very similar. Australia has something very similar. Like I think FHIR is starting to get like legislated a lot more. So you have people who are forced to like build all of these tools so that people can like use that. But I think going back to the discussion, right? Like I think if I look at this, diagram, right? Assuming that we don't have FHIR, we don't have OpenHIE, we don't have anything, like let's assume that we just don't have any of this discussion at all. What I'm thinking is a normal data architect would come here and they would probably think about just two things. They would probably think about, okay, I need a transactional OLTP system for day-to-day workloads. I need to model my data in there so that it's transactionally stable. It needs to be like, let's say, third normal form at least. And there are these different constraints for the transactional system. And for the warehouse, or you ideally want to use a columnar system, you want to use something like Kimball's dimensional models. So the problem that I see with both like OpenHIE and FHIR is that a lot of these techniques are completely thrown out the window most of the time, right? Like, so even in FHIR, I had this discussion last time where somebody wanted to implement I think AWS Health Lake for their whole transactional system, and then we found that it's not really transactional in that sense. Like, you can't really wait for you can't have snapshot isolation, for example. You can't have serializable transactions. So these are actual, you're giving up on a lot. You're giving up in terms of what you expect of a normal RDBMS database, right? Like, you don't get the exact transactional semantics. And in healthcare specifically, because we are putting all of this as JSON, there is just so much denormalized stuff here. There is so many different ways to represent the same stuff. So I'm actually of the opinion that this works. The shared healthcare record, like, it's there in FHIR, it works. But Daniel, like, honestly asking you, if somebody gave you, for example, the data models, right? Like, they're like, here you go. These are the data models in SQL. Let's say OMOP was a little bit more extensive. OMOP did not, only talk about the research side, but they were like, okay, like, we are going to capture all of the healthcare data points. Maybe they copy the CKM from OpenHIE, and then they put that all in like raw SQL. Wouldn't training developers to just work with normal, like, things that they have already used for years, like SQL, Postgres, wouldn't that have been a faster and easier and cheaper solution?
I completely feel you. When I started off working with FHIR, I don't know how often I cursed, coming from a data engineering background. Oh my goodness, all these JSON parsing it's just too much. And what I see happening from the data engineering community with technologies like DuckDB and Polars, we should not throw out these principles out of the window. But the new generation, I'm over 50, so if you allow me, they have forgotten about that. You need to be specific about for which context and which technical performance parameters you optimize. And I've seen it happening over and over again. And indeed, if you were to give me a data model, and if I were to follow along in this thought experiment, if I, again, today had a kind of carte blanche, how would I do it? My first idea would be, are graph databases robust and performant enough to serve as a transactional system in this, as the shared health record? Because then it is the most flexible and also the most expressive. Because then your schema evolutions are far and far easier. That would be my thinking.
I actually have a
Actually, in the
yeah.
EHR vendor in the Netherlands that's built their EHR on a graph database, and they do have some scale. And never heard them about performance problems, but interesting enough, one of the key people there said he would consider, what's the name again, like a time-based, a transaction-based database instead of a graph or a relational one, because the EHR is so time dependent, like changes over time, different editions.
Yeah, you do event sourcing in probably something like a time series database, because that's optimized for incoming events and incoming messages, something like that. I would think that he's referring to.
XDDB is probably a good, it's I think they call it bi-temporal. So like, you have event logs as an automatic side effect of the data model.
Ah, okay.
There's a bunch of, I actually also want to like bring your attention to this paper. Like, maybe one of you have read this, like Michael Stonebreaker. It's a very old piece, I think 19 something. Like, what goes around comes around, and this, they talk about the whole 35 years of like data model proposals. Like, they talk about graph databases, XML databases, like all of these different. I think there was Codacil at one point. then there is a relational, there is the entity, there is a semantic. So just like quick, okay, I'll ask you, like, what do you think what do you think the conclusion here was? So they compared all of these, and then they are trying to report on what the most stable or like what the best way to like do things is at that particular point in time.
I honestly haven't read it. I would guess let's all go back and reread Cott's paper about relational modeling.
Yeah, I mean, so here again they reference back to cards. This is like I think 30 years after card, and they basically end up with like, oh, we know these cool stuff exists, like the object-oriented databases were there. There is the graph databases. There is other stuff, and they basically end up saying that. I think the conclusion kind of caught me off guard. It was pretty well put. So basically, they're saying, do not repeat history. Please stand on other people's shoulders. And they're like, this still RDBMSs with the relational model is basically unbeatable, right? And actually, there are two papers. So there is one called "What Goes Around Comes Around," and they compare like the last 50 years or so. Then they published a new one, I think like this, just like last year, I think, "What Goes Around Comes Around around," and they again like talk about the recent changes, like the map reduce systems, the key value stores, like document, SQL, NoSQL, as well as column stores. Again, surprisingly, they end up saying that you still, you have all of these new changes, but relational models are still or more or less unbeatable when it comes to the transactional isolation guarantees and so on. So I don't know what to like think of this. Maybe it's just like a sign of this time, or maybe like these other databases are yet to grow out of their infancy, like graph databases and so on. What do you think, Daniel? What is your take on this?
Intuitively, and just from my own experience, because I'm definitely not a full-blown database expert, I would agree. And for the very simple reason that SQL is, I could have the same argument for SQL. I've been teaching data science and AI for over 15 years now. And when all this started happening, data science being the coolest job, everyone went on and bashing, oh yeah, you're an old school SQLer, database or whatever. Let's do all the hip and new stuff. And I said, no, don't do that. It's nonsense. And now going forward in a very similar vein, I'm a big fan of what's called the composable data stack, which is also referenced in the paper. There's the composable data manifesto with people like Wes McKinney and etc. And they said we should not throw this out of the window, but we have many new technologies, and we need to make sure that they interact more. So we need to decouple storage from compute, and we need to decouple the APIs, in this case, whatever SQL flavor, from the actual execution engine. And I think, that's also systems engineering 101. Thou shall make composable components. And I hope that, since the 2000s with the whole internet and data gold race, I would almost say, that in the coming, say, decade, we kind of reinstate these old engineering principles and make sure that we move towards more robust and more composable systems. Because also in my client work, I work as an independent consultant like Joost. It's of course it's easy, right? Oh yeah, that's just one contract, one ecosystem, one often big tech lost because you can't swap out anymore. So also in the context of the current discussions, at least in Europe, on digital sovereignty and data sovereignty, that to me is also ties into this discussion. Yes, we should reinstate the old principles, very fundamentally, but the technology stack looks different. And I would say, let's use the fact that we have such a rich ecosystem of different components. And that's our work as engineers, as informaticians, to make sure, okay, which configuration is fit for purpose for whatever project that you're working on.
And Daniel, we could come back to the performance of the shared care record component that's currently in FHIR. I'm
Mm-hmm.
really keep coming back to what you said around what do you optimize for and what are your requirements? Because in theory, as we discussed, there's performance limitations from the OpenAIR and FHIR way of persisting JSON-B in Postgres. But on the other hand, we have some experience where we compared performance of OMOP on a traditional SQL model and raw AQL on the same setup I
Mm-hmm.
described before.
Mm-hmm. Mm-hmm.
We entered data for 100,000 synthetic patients with
Mm-hmm.
one or two diagnoses. And then we indexed those, and the performance was super similar. It was 1 second for OMOP and 1.1 second for OpenAIR database. And this is negligible in clinical settings, I would
Yep.
say.
Yep.
And in a research setting, it's totally irrelevant. Data collection usually takes months, sometimes years. So running a query that's 0.1 second slower, yeah, they're totally different order of magnitude. So I wanted to know a bit more about what are the performance characteristics for your server, because we didn't talk too much about concurrent writes, and I would assume those are quite important. And there's been quite a challenging paper by Google a few years back on the
Yeah.
performance of the FHIR servers out there. And of course, part of the paper was that they do much better with their spinner server. I don't know much about the technicalities, but it could be interesting to talk a little bit about that if you want to.
Yeah,
Yeah.
yeah.
So
On my
first,
blog, right? Like FHIR servers are unusable in production. Wait, I'll just
Yeah.
take it down.
oh, you're on the blog post on that. Okay.
Being
Here he
articled
comes.
this is by Vivian. This is by Vivian.
Yeah.
I think she's the CTO at Google. She just like benchmarked HAPI FHIR and was basically like, nah, it doesn't work. There's also the white paper, of course. But Daniel, what was your opinion here?
So first of all, this was not my focus in the work that we're discussing here. I've had the pleasure, though, to be part of this SQL-on-FHIR community working group. And that's very much led by the people at Health Samurai, the makers of 8box. And I understand that 8box, but I'm not completely sure they don't use JSON-B. They use it.
They use 100%. They use JSON.
They use it. Okay, they use JSON-B. Okay. And the way I understand is that performance there, it's definitely in production at the scale of health ecosystems, millions of people, etc. Whether that's good enough or not, and what happens if you want to have a national shared health record, I would say for different reasons, don't even go there. I'm thinking more of a federation of these things. That's definitely something that we have to look into. And I agree with Joost. I think that's an engineering, that's a hardcore database engineering issue. And that's what I also often find is that in my work, and I assume it would be the same for you guys, we kind of, mix and match different learnings and concepts from 3, 4, perhaps even 5 different communities of practice. And I think bridging those is already part of the challenge.
So you also don't have any hard data on the performance characteristics?
No,
Okay.
no,
Because
no.
there's been a recent discussion on LinkedIn triggered by one of the most interesting FHIR experts, Darren Devitt. He was saying FHIR is not a database. And he put it out there as a bit of a challenge because there's quite some nuance. But
Yeah.
there was this FHIR expert, Rick Smithies, if I pronounce his name correctly, and he was referencing a few projects that actually do this, put FHIR as a database on a national level scale. But it was very hard to get specific performance characteristics other than people do it. But it makes all the difference in the world. How many patients are there? How many concurrent writes? How many analytical queries? Do you actually validate the FHIR data coming in? I mean, if you don't validate, that's a huge time saver on doing the writes. But yeah, then what does your data mean if you don't even know if it's technically valid FHIR data? So of course you can take all kinds of shortcuts, but what do people actually do? And I'm so amazed at how little knowledge sharing and how little information is out there on this topic. We really, really need this, in my opinion, because unfortunately, another explanation why it's not there is because it is just good enough. But I'm afraid that's not the case, right?
Not good enough. Yeah. No,
I
and
mean,
perhaps also for the audience, one of my favorite books is by Martin Klapman, who's a university lecturer in Cambridge, designing data incentive applications. It's one of the few O'Reilly books that I read cover to cover, and he's in fact writing the second edition. That's my go-to Bible to make sure that we don't forget all these data engineering principles. And he also goes, in great depth, comparing, for example, federated data platforms, operational data platforms, and the pros and cons of having one centralized monolith, so to speak. And everything comes at a cost. And personally, intuitively, I would say, given all the discussions and the breaches and the inherent properties of federated system, we need to, step up the game in our field of work, namely healthcare informatics, to take on board all these principles. I have seen federated openEHR configurations, which I think is great. And there won't be one central database to rule them all in any which country because it's just asking for trouble. Indeed, I love this. I love this picture. That's it, right? You need to tick them off one by one. And I think very few healthcare systems tick these boxes.
yeah, the funny thing is that I actually started reading this book very recently. And then I'm just like, I'm almost like in the last chapter. But the whole thing about reliability, scalability, and maintainability are not really covered when it comes to defining a health data platform. So I was just looking at Aperta's definition of an open health,
Exactly.
and they're like, yeah, okay, there is all of this, these 8 different criteria. Okay, it should be operable. I think the only thing that come close to maintainability is
Yeah.
operable, right? Which is
Yeah, but it's much more than DevOps.
which is a very subset of maintainability. And I actually think, going back, looking at all of the definitions of like what is what, we got to go back to the basics. I think we just had to look at standard industry definitions and then build on top of that instead of like inventing our own stuff.
Yeah, here. Nothing to add. Yeah.
So
This
here,
is one of the issues in our field, right? It's so complicated, and there are so many aspects that it's really hard to write a paper like the Aperta one, because I really like the paper. It's a great paper. It has a lot of important insights, but of course there's aspects because the challenge is so huge that you don't cover.
Yeah.
Considered actually, because we now have been talking about the technical side and the performance, and we concluded that at least in theory, the challenge is the same between FHIR and OpenAIR. But I wanted to spend some time on comparing the semantic differences. Is that okay, or where do you want to
yeah,
take
no,
our conversation?
for sure, yes, Stuart. Before that, I want to, what is that paper that compared OMOP versus OpenAIR queries? Is that a paper or is that just a result that's published somewhere? The performance that you said, the 1 second versus 1.1 second.
Yeah, it was an internal project of a few organizations in the Netherlands. And I think it's published somewhere, but you would have to ask Igor Schoonbrood. You know him, right?
Okay, got it. I think I'll put that down below as well if we can find the reference. But let's go back. I think, yeah, Joost, let's talk about the semantics and let's talk about that part.
Semantic debt.
Yeah, so we were talking about real world examples of queries, like give me all my patients with a fever, or give me all patients with, I don't know, inflammatory bowel disease who have a high blood pressure. And one of the key differences between OpenAIR and FHIR is that FHIR at the base level doesn't define any of these models. It doesn't define blood pressure, it doesn't define fever. All these clinical concepts are in the profile space for FHIR. And it makes a lot of sense for their paradigm of just building a framework that gives developers the tools to easily integrate to different systems. But if you, like your example in Kenya, you want a shared care record, then you want to be able to perform queries like this. And if you then have different applications that write similar data to the same record, for example, the midwife could record a diagnosis or blood pressure, and some other, I don't know, ophthalmologist or some other doctor could write it. You want to know that this data is comparable, and you actually need quite a lot of standardization on the semantic level in order to be able to actually compare this data. And OpenHIE delivers a lot of that, both at the modeling side. So there is an internationally validated model for body temperature, which allows you to query for fevers, and one for blood pressure. And so there's hundreds of models that have been rigorously validated. And on the FHIR side, you could implement the same models, but it's not part of the core spec. So different use cases, they build their own implementation guides with subtly different implementations of the same concept. Like a blood pressure in one implementation guide is not necessarily the same as the one in another. Like, for example, the condition, there's a huge difference whether the midwife makes a diagnosis or the gynecologist. Not even saying one is better than the other, it's just they have different standards, different definitions for when to record the diagnosis. So that's a huge challenge, that it's abstracted away if you say, well, we can persist data in FHIR, that you actually don't have comparable data. And the other side is we briefly touched on the query language in OpenHIE, the archetype query language. It's actually built to perform queries like this at the archetype level, knowing that you persist data from combinations of different archetypes. So if a midwife records some data about a pregnant woman, they also record the blood pressure, but they also record the fundal height and the age of the patient, all this stuff, and it gets persisted together. But you need to compare it with a different data collection from a gynecologist or somebody else. And it's really hard that FHIR does offer search, so you can technically express parts of these queries, but these queries can only be reliably performed on a single implementation guide. So if you have the different implementation guides for the gynecologist and the ophthalmologist and the midwife, which you probably want because they're very different use cases, very different implementations, that you can't actually semantically query across those. Well, you can syntactically, so technically you can query, it's just that you don't know if your data is comparable. So I find this mind-boggling that this gets talked about so little. There's a little bit of talk about the proliferation in FHIR, but the query side is really not talked about enough. I mean, it's just people assume that one blood pressure is the same as another, but it's just not true. It's crazy risky in my opinion. What's your experience with this, Daniel?
I have some experience, but far less than what we've discussed so far. And yeah, to put it very shortly, I completely follow your line of reasoning, and I fully agree. What I find difficult, and I actually like the phrasing semantic depth. Perhaps we could do something with that also in our common work here in the Dutch context. I think we're looking at a huge semantic depth. And if I look at healthcare informatics experts here in the Dutch universities, they see the same thing. And I really think that, ontologies, graph technologies, and not as a technical expression of information, but the concepts behind those are the way forward. And I completely see that OpenEHR, that's one of the key strengths of OpenEHR. And if we can bring that together, that openEHR, like we've discussed, Joost, could be used as a starting point of a formal clinical ontology, and we can build on that and make sure that we don't reinvent the wheel. I think that's a far more likely world scenario, rather than just bringing, I don't know how many hundreds of different profiles with one-on-one mappings, which is going to be unmanageable. It's because we need to ground it in ontologies. I'm a big believer of Sir Tim Berners-Lee with his Web 3.0, but he was way too early, and hopefully now we do have the technologies. But that also raises the bar for ourselves and our colleagues. It's yet another community of practice, another set of technologies that we need to include in our stack. I've started working with ontologies and with graph databases, 2 years now. And it takes a lot of getting used to coming from where I come from. So, and that's probably going to be, we need to take that hurdle as well.
I think I just want to add here, I think the main idea in how OpenHIE solves this is maximal modeling, right? Like you don't let implementations define this additional stuff, but you define as much upfront maximally and let people extend. So like I'm actually thinking the more I look at things, the simpler and less complex something, the better, right? Like, so I think there is even this thing called like the Jersey style or something where they say worse is better actually. Like, so they compare these two systems. They are comparing like Unix, which was doing just like one thing, but they did it like on multiple architectures. And then there was like Multics at that time. And Multics, like in every way possible, was better in terms of like how they've architected. All of that is better. But like Unix just ran on more systems. Like you could just take more stuff and like run it directly on Unix. So I think the Jersey style versus like the traditional approaches, worse is better. Like the worse you have something, it gets adopted because it's simpler. And they even say like simplicity is better than being correct at some. I don't know how much to agree with that, but it seems like
the phrase comes to mind: the better is the enemy of the good.
Better than as well. Are we talking about the OpenHIE company? No.
Oh, no. Sorry, no. That was not a pun intended. No, there was no pun intended there at all. It's literally a phrasing that I've heard English people use. That better is the enemy of the good.
Yeah, particularly fun one is this from surgeons. I don't know if you heard this one, Siddharth, but during operations, the surgeons they really should aim for good enough because they say good, better, oops. Let's say oops, but I don't want to swear in this podcast.
Yes.
No, it's not a saying here. Probably a Dutch saying. I don't know. So no, this has been good. So I think like at the end of the day, maximal models is probably what defines these semantically. I'm gonna call it like semantically unambiguous entities. I don't know how else to like properly define it, but like if you have FHIR is notorious for not doing this well enough. Like every single FHIR project that we worked on, like I swear, like we worked on something with like GE Healthcare. They were pulling data from like massive sources of FHIR data, like every single hospital almost in the US, every single version of, and we are doing like clinical oncology decision support, right? Like, so like very, very practical thing to do. We just wanted to find out what the tumor size was, or like what exactly, like what stage of cancer that the patient was in. Guess how many different definitions of this was available in. You can look at an observation with these codes. You can look at a condition with these codes. Oh, you know what? Sometimes it's actually in the imaging report with this. Like, so it's just so much ambiguity in representing that same data. Definitely. But again, like Joost, coming back to you, OpenHIE, I'm not sure about, has it solved this problem completely? Or are we still looking at the template in OpenHIE as the level of interoperability? Because again, in FHIR, we have profiles and we have implementation guides. And like, if two people are using the same IG, then we know like at least, okay, they're going to use the observation in this possible way. That's not true most of the cases, but yeah, maybe. But OpenHIE, I'm seeing people like, again, especially when I'm trying to teach OpenHIE to new people and like they're just starting with the archetypes and they're putting things together. They make these mistakes all the time. Like they represent things using different archetypes. They represent things within, for example, even the medication archetype is so complex. There are so many different ways to represent that same exact model, right? Like, okay, do you put a coded text when it comes to repeating cycle, or do you put it as text, or do you put it as, so what do you think? Like, has OpenHIE with the archetypes and maximal modeling really solved this? Is it like semantically unambiguous, or are we still operating at the level of a template?
Yeah, great question. I've been thinking about this quite a lot over the years. One of the key discussions where this came up is the querying work group of the OpenHIE specifications committee. And basically, the query language is designed to query at the archetype level. So if that would be perfect, you would not need a specific template included in the query in order to get your results. And then one of the remarks, so it was around how do we specify how to filter on the template in queries. There was a discussion. And then one of the technical leads of one of the major OpenHIE CDR implementation that implements this query language says, so in theory, you shouldn't need the template. And then on the other hand, all of my implementations filter on the template.
Okay.
So I think that partly that's your answer, Siddharth, that apparently in practice we are not there, that you can just query on the archetype without filtering on the template. And on the other hand, everything you need information-wise is there in the archetype. So for example, if you want to compare blood pressures for, I don't know, 2 patients or 1 patient, different measurements, you want to know that all the other influencing factors are constant, like the same device, same patient position, same eating habit, and all that data is in the archetype. So technically, you can build a query that filters for a good comparison. But then you also need to know whether that data is present at all. And that's usually done in the template. So it means something else. If something is mandatory and not there, means something else from it's not there and not mandatory. So if some device is mandatory to be filled out for blood pressure measurement, if it's not there, then probably you want to ignore that data. On the other hand, if you in the template don't force the device to be recorded, could very well be because the entire organization always uses the same device. So there's no point at all in recording that data. So still in the details, there are some information in the template. So the way I'm thinking about this is that probably you could create like a whitelist for a specific query. You could whitelist a bunch of templates where this query is valid for. I think that's currently the sweet spot. Because also you need quite a lot of other information on different layers of the interoperability model, like process-wise, you need some standardization, like policy-wise, you need some standardization, maybe infrastructure. If there's a huge delay between recording and persisting the information, or this kind of, it has so much influence, all of it. So you need to standardize all the layers in your stack in order to be 100% semantically compatible. And on the other hand, very, very often it's just good enough. If you can filter out a few key parameters, like device or like patient position, especially at scale, like you want to know the average blood pressure of a person in the Netherlands or worldwide. The numbers just are so huge that the differences or the niche differences between data points, they start to get less relevant for specific research questions.
I think
So
there
yeah, a lot to
is
say about it.
Yeah, no, I understand the take here, right? Like, so there is some context that's in the template. There is some, intrinsic context, like while somebody is building the template, they know the defaults, so they don't really put it out there in the template, like while capturing information. So I think that brings me to, I think there is some sort of an impedance mismatch between sending messages out of your system versus like keeping things in and like querying. Like, and again, like for the audience, the impedance mismatch term comes from the object relational impedance mismatch, where like if you're using a programming language and you're trying to represent data in SQL, it's not easy. It originally comes from electricity and like electric circuits. But I think there is a real impedance mismatch in terms of domain model for storage and for transactions versus the messaging model, right? Like in a messaging model, you will always want to send as much context as possible. And in a domain model, you want to store as little of this default context as possible, right? Like, so because you want to avoid the stuff that you already know, you don't want repeating data. You want normal data in like nice little tables. So OpenHIE is sort of this, like, I don't know where it stands on this. Like FHIR is clearly, hey, I'm all messaging. People are using it for storage. Okay, fine. It's okay. But Graham has clearly said like, okay, we made FHIR specifically for messaging. We know that it's supposed to be used in this denormalized way. Like a patient is going to have 50 identifiers. An observation is going to have like 20 identifiers. Completely fine, because when you're sending it out, you want to send out as much context as possible. OpenHIE, on the other hand, is sort of like, I don't know, like it's almost like, I think if we look at the original architecture diagram of OpenHIE, you see like this shared care record and then like separate CDRs, right? Like each hospital having their own CDR, and then all of them send data back and forth to this shared care record, and then like they exchange information. So in a sense, like OpenHIE, is it still in that interop kind of a space? Like, is it optimized more for the messaging model, or is it optimized more for like storage and query? Like, what do you think?
Yeah, it's funny that you call out this paradigm from electrical engineering, because maybe you know, but the other founder of OpenAIR actually was trained as an electrical engineer,
That was weird.
and he said that this helped him a lot in understanding the medical domain, because it's all feedback loops, both electrical engineering and medicine. So yeah, I couldn't resist remarking on that. But to answer your question, Siddharth, it's definitely OpenAIR is still more focused on the persistency. And this is another key point, I think, from the paper that I want to get back on, because it's very different. FHIR is definitely focused on the messaging or APIs, but definitely integrations between systems, which could be tiny, could be just, I don't know, a patient resource with just a name and an identifier shared between some systems. And that could be a valid FHIR implementation guide and could break up a lot of messages. But of course, the scope is tiny for that. So it's quite easy to have a lot of FHIR implementations, is what I'm trying to say. And it's super valuable. I'm not disregarding the value. But then on the other hand, if you look at OpenAIR, definitely they try to solve the whole problem, the boiling the ocean, as Ian McNichol often says. So it's super hard to get an OpenAIR implementation up and running. But if you do, the value is huge. So I always take issue, and also in this paper, that the usage of FHIR is said to be much greater than that of OpenAIR, because I think it's not a very useful comparison, because the scope and the value is so different for one implementation versus the other. And then finally, also I find there's a bit of lack of references for this data, that there are more FHIR implementations in low and middle income countries compared to OpenAIR, because I think it's so anecdotal. I mean, you give a few examples of FHIR implementations in Africa, but I could give some others also in Kenya, but also in Nigeria and other countries. And the other thing is, often you don't know. I mean, nobody is forced to report whether they use a FHIR or OpenAIR implementation. So I would be very reluctant to draw conclusions on the quality or the applicability of either standard based on that. I mean, it's fair to say, if you the one I really liked about your paper is the GitHub results, like how many projects are there for FHIR compared to OpenAIR. And there it's very clear that if there's more tools available on GitHub, that's a huge pro for the FHIR standard. And this is also increasingly being recognized by the OpenAIR community, that we would like to be able to benefit from the from the FHIR technology and the FHIR ecosystem in the OpenAIR world. And I think it's very, very doable. So yeah, I really wanted to make that point.
I think it's an absolutely fair criticism. Again, it's just my observations, having worked for Pharmaxis for 3 years. I've never come across OpenAIR. I've never come across OMOP for that matter. I have come across OpenMRS, but I briefly alluded to why we disregarded that quite quickly. And I do sincerely hope, because you told me, Joost, also that, of course, the OpenAIR community keeps on developing. Given that it's also far more of a greenfield situation where many healthcare facilities in these countries do not have any basic infrastructure towards digital health. If we could indeed, as an international community, help them by implementing, for example, as of today, an open-air shared health record in some country covering a couple of million people, I think that would be a great project. I just haven't come across it. I haven't. But I could see it working because I think it will also help in making a major step forward in terms of the quality, when the data is actually being entered in the first place.
Well, I want to dig into that a little deeper, Daniel. So I think OpenMRS, of course, there is just the normal OpenMRS, but there is also this project called Bamini, which again, they basically build it for low resource settings, and they are like, okay, we use OpenMRS, we'll use Odoo for the ERP, we use TCM for Chi, OpenELIS. Doesn't this, I think going back to the diagram, it's almost like most of these modules here, right? Like, doesn't something like Bamini immediately cover this? Like, instead of building it, why not use something where this was already done? Like, what is the exact, what happened here?
Yeah, so the way I see it, these are the systems where each healthcare facility needs to decide for themselves, am I going to adopt and implement this or not? And that's not on my plate. So I can influence everything that happens in the box of OpenHIE. But I have far little direct influence about what each clinic does or what each pharmacist does. And these are also the long-running projects, the kind of holy grail approach that we've discussed earlier. And from that perspective, my focus really is the HIE as such. And I could not see why would I use OpenMRS as a shared health record? It has far fewer interfaces or components that I could use out of the box. I could use Odoo. I'm a big fan of Odoo. In fact, I'm using it in the Netherlands now because I have never heard of Odoo until I went to Africa. I'm like, oh, hang on, that's actually quite a mature ERP system, which is very modular. So that one I could see. Yes, definitely.
Got it. So here, I think, the whole appeal of Bamini, I've seen it being implemented in a lot of low resource settings, is that you get everything boxed in as a bundle. And basically, you have the healthcare module using OpenMRS, you have the ERP stuff using Odoo, then there's the labs, and there is the radiology. A similar approach is also like Frappe Health. Not sure if you've heard of it.
I've heard. Again, but this is also all at the facility level, and that was not our focus.
Got it. So again, like the answer here is no control of this, only control of this, and putting in an open source stack here doesn't really make sense. Okay, makes sense. Joost, I want to quickly ask your opinion on the recent OpenAIR based package for FHIR. And so again, this is, I think Graham Greave is technically working on this. Let's just see the GitHub, see when his last commit was. I think 2 months ago, Graham Greave. Okay, cool. But I think
he told me.
Yeah, what do you think about OpenAIR archetypes being represented as FHIR resources? Right? Do we sort of get the benefit of both worlds? Do we lose the benefit of both worlds? What happens if something like this were to, go through?
So this is another funny story, I think. So I really appreciate Graham making the effort of creating an OpenAIR reference model representation in FHIR. I think it's super, super valuable. And the funny thing is that I've been thinking quite a lot about how to do this automatically, how to generate FHIR logical models from OpenAIR reference model and archetypes. And I thought I was just needing to find a smart person with a bit of time to do this and trying to, at the same time, optimize the OpenAIR source of truth in a way that's easier computable than the UML it's currently in. And then Graham showed me this, and I was quite impressed. And I was like, how did you do this? Well, he said during meetings. So he met during meetings, he was just by hand creating all the logical models. And I was like, okay, apparently I was
Excellent.
overthinking this. If the smartest guy in this world or on this topic does it by hand, I was overthinking it.
This
But
the point.
anyway, content-wise, we already discussed the value of the CKM clinical models for like
Yeah, that one.
also in the FHIR world, like for specific concepts like diagnosis or blood pressure or medication prescription. And there's different ways of doing it. And I've been quite involved in the Netherlands way of doing this. Currently, the Dutch national models for similar concept like blood pressure and problems are expressed as some logical models, not FHIR logical models, and then technically implemented as FHIR profiles. And they struggle a lot with implementation differences between implementation guides. So they are now looking at OpenAIR because it offers more consistency. And we had the challenge, so how, if you have OpenAIR source artifacts for specific concept, how do you represent that in a FHIR profile? Because FHIR profiles will also in the Netherlands be like the required format for laws and standardization. I don't at all think we should mandate OpenAIR as a technology for standardization. It's just a tool to get to the integrations in the end. But I had two diagrams whether to go to use FHIR logical models as an export option of the CKM and then create profiles on that. But in the end, I ended up with suggesting not doing that because you lose so much semantics once something is a FHIR logical model that it's hardly useful to my use case. So you can't compute, for example, on the logical models because there's so few semantics there that your algorithm to process this to put it into an implementation guide is really hard to build. So currently, I'm more thinking the OpenFHIR work, which Siddharth was a key enabler for that, where you create a mapping between an OpenAIR archetype and a FHIR resource, and then you create specific mappings for specific implementation guides between an OpenAIR template and a FHIR profile, because then you have the hard semantics, and then you can reuse the mappings, and you can do the archetype to resource mapping at an international level. I think that's a much more scalable way to actually implement OpenAIR data transformation in production to FHIR profiles and FHIR resources to actually exchange. But it all depends on what you're trying to do, because in the Amsterdam event, the FHIR people were already very happy if they could use OpenAIR archetypes as design input for some implementation guides. And then this logical model is super useful because then you can just put it in there as design documentation, that you put this in there for reference, because the FHIR logical models can be built into the FHIR implementation guide, which is super nice formalism for writing down the agreements we talked about before, if you want to actually share information, and OpenAIR doesn't really have something similar. So it's super useful for some use case, but for what I'm working on, like creating a scalable health data ecosystem with consistent semantics, I would see much more in the OpenFHIR approach, where you say the OpenAIR CKM archetypes are semantically the source of truth, but practically we exchange data using FHIR resources.
What comes to mind, and first of all, I have far less experience in OpenAIR, but what if we take that approach that you propose, Joost, and use graph databases just as our toolkit? Because I know that there's already graph representations of the whole FHIR standard. And I think it's doable to have, you know, the whole ontology of openEHR into a graph, and then you would build literally one graph database where you do this maximal modeling, as you call it, Siddharth. And then on top of that, I really believe, you know, for the same reasons that SQL is here to stay, I think query languages like Sparkle and Cypher, you know, I'm very hesitant to introduce domain-specific query languages. But you know, Sparkle is very, very expressive, even for, you know, all these very super detailed use cases. And then also in terms of capacity building in whatever country, you know, it's, you know, it's there.
Yeah, no, I think it makes sense. I think I had this a very similar discussion with Josh Mendel from the FHIR side. I think he was initially trying something very similar too, where just represent everything as OWL, right? Like ontology web language, like put it out
Yeah.
there. Snowmed already has the ontology. FHIR
No.
already has
Yeah.
some sort of
Yeah.
ontology representation. And then once it's in the graph, then like you can map and make sense out of like what is what, right? Like,
And you
then
can start real reasoning, so not LLM reasoning, but graph reasoning, and you know, using computations to filter out inconsistencies or loopholes or what have you. But I think that's there, and I think that would be, of course, it's what we call in Dutch monk's work. But if you have that central database, we can all contribute to that.
I don't know how to feel about this actually, because like it's always usually the solutions that work are like the dumbest. Like for example, yes, like Joost was talking about logical models, and yes, all of that is great if we are able to convert that. But a picture of the CKMs, the graph, like just putting the picture, giving it to another modeler, also like sort of works, right? Like I'm like looking at similarities and. Uh, Honestly, like, okay, like we did OpenHIE, we did open source it. I think like MedBlocks, we bought OpenHIE out for a project, and then we were like, okay, let's open source this now. But honestly, it's hard for us to work with it because the YAML definitions are the limiting factor here, right? Like, so we have to write those YAML in FHIR and OpenHIE. And for us to have somebody write that, we need expertise in both FHIR and OpenHIE and OpenHIE. Like they also need to know how the engine works and the nuances of the engine. So honestly, like what we found out is that in the era of LLMs, in the era of assisted coding and whatnot, it's easier for us to just do this in a language that the LLM is really good at. And there's like a lot of research and like a lot of talks on this as well. But LLMs are really good at popular languages. They're really good at
Yep.
like, for example, like so many companies have moved from their own like front-end framework. All of them have moved to React. And the reason is like LLMs perform 4 times, 5 times better on a React code base because it's just seen so much React code. And like it comes back to this like the road and car analogy. Like you can sort of like innovate like what a car should look like and what a road should look like. But once you have the roads laid out, and once you have like the dividers and the size of the thing, like there is only so much you can do with the width of the car, right? Because now the road is already there, and you gotta like make sure the car stays on the road and like it works. So I'm thinking LLMs and AI and generative AI in general as a sort of this. I don't want to be too pessimistic about it, but it seems to be that if a problem can be solved in a simple language that's popular, a developer with LLM is going to be 10 times more productive using that than a domain-specific language that was meant for something else. Like, again, I would not have this opinion before LLMs. Like, this is only because of the speed increase and all of this that we are seeing. So, like, I don't know. Maybe it's better, but then maybe also like somebody just takes a screenshot of this and then passes it to an LLM, and then it's able to figure it out, make the connections, write simple, I don't know, like SQL, or, it matches up the semantic differences, and then someone verifies that. That could be possible as well.
Yeah, so the way I proposed with standardized FHIR Connect mappings that OpenHIE can use only works really well if your FHIR profile semantically conforms to the OpenAIR archetype in the first place. Because if there's different meaning in the FHIR profile and in the OpenAIR archetype, it's super hard, usually impossible to do the mapping. And if you let the developer do it, they will find a way, but it's super high clinical safety risk if you don't verify that clinically. So in the end, my assumption is this mapping one-to-one is never going to work reliably outside of a highly controlled context. I mean, of course, integrations work for specific contexts like labs or, I don't know, statistics data or whatever. But so this is my assumption. We need to standardize the source data according to the OpenAIR CKM models. And it doesn't have to be in an OpenAIR CDR. You can indeed give, as Siddharth suggested, the picture of the archetype of the data model. Maybe you can put one on the screen, Siddharth.
Yep.
With some logical constraints. Any EHR vendor should be able to build that in their current stack, whether it's Java or .NET or whatever exotic thing they use. As long as you can build a model that conforms to these constraints, it should be fine. But I can see that what Siddharth describes, if you don't have this, if you have different target meaning and different source data meaning, it's super hard to find people who can do the mapping, especially if they also need to learn OpenFHIR. So in my world, this would be only a tiny percentage of the work for specific projects because most of it should be done by the people behind CKM. They should create FHIR profiles for the OpenAIR CKM archetypes and include FHIR Connect mappings and might even be able to generate one from the other. It's an interesting question I have. But I would actually like to go into the LLM part because also in the paper you write something about this, Daniel, that I disagree with. You write that given the health data standardization will continue to require mappings. We propose to explore the use of machine learning and particularly large language models as a means to reduce the development efforts required to create transformations between various health data formats. And I'm really skeptical about the use of LLMs in this regard, because LLMs are inherently faulty. They are prediction machines that have a threshold for accepting a suggestion, a probability threshold. So they are never 100%. Same for humans, by the way. But I would think like how do you use this? Because you probably want to have this clinically verified if an LLM suggests a mapping, and then still the person judging that needs to be smarter than the LLM and still needs to understand both FHIR, OpenAIR, and the mapping language, whichever one you use. So yeah, it could speed up people doing mappings for trivial things. But on the other hand, trivial things are not really the issue. It's easier to find people to do that. Or as I suggested, if the CKM does it, it should be solved anyway. So the only thing I was thinking it could work for research, that if you know a little bit about the error rate of an LLM for specific mapping, that you might be able to relate the p-value of your statistical reliability of your results. I could see that work, but it's like quicksand. Everywhere you look, you get issues, and you don't know anymore what your data means. And I'm really concerned about this. So I'm really curious for both your responses because you're both much more experts in the LLM area than I am.
Yeah, so first of all, I think I agree that we need to be cautious with large language models because hallucination is still a key issue. And also here, the way we intended that comment is a bit more down to earth and far less earth moving than perhaps that you understood it. So literally, and this is also a shout out. We worked with Beta Software, Ilya Beta in Australia, and he ran into the same thing. Just in the field, there were tons of just one-on-one mappings going from one context to another, without having the full-blown, say, maximal modeling again approach that we discussed. Now this was far more hands-on. So the GitHub repo is available. He made a first implementation, and we reached out to him. We, in this case, Farm Access, saying, "Look, we could see this happening, right? Because it's just in very, we're not trying to solve the bigger problem of CKM, but just going from one project to the next, from one source system to the other, and how could we make sure that clinical people who can't write code, but we can teach them to work with YAML files, that they can exactly do what you propose, Joost, namely that they have a means, a tool, that they actually do the mappings. Because I've done that with people with a medical background, and I just literally sat to them next to my ID saying, okay, these are trivial because even not being a doctor and having done this often enough, I can do these mappings, but these are the critical issues. But ideally, I would like to do a person to do that. So that's what we developed first off. It's a FHIR path mapping language because there's many templating engines, right? Jinja, you name it. But again, here we wanted to stick close as possible to the FHIR standard, and that's FHIR path. And in fact, FHIR path can consume any JSON. Although it says FHIR, it just looks at key value pairs and then it traverses it. And Ilya already had done of desk research to how he thought about it. And he also said it just so happens that LLMs, they work best if you prompt them using JSONs, if the input and the context is given in JSONs. So we literally had a small project. We asked them to build a Python implementation of their original idea. That's open sourced still, so the Python version is available. And we made our first mappings using their FHIR path mapping language. And my simple idea was, once we have done 2 or 3 of these things, we can give this as example code. I use Gemini most. And I know for a fact, the 4th project comes along, and I know for a fact that my colleague data engineers in Nairobi, they will just have to check it. And it's far so that it's really more as a coding tool, as a mapping tool, rather than relying on LLMs for the actual human knowledge or hard-coded knowledge that we have. It's just a development tool.
I think for the viewers, that we do have another video with Ilya showing this mapping. I think he uses 8box on the FHIR mapping. He came out previously, so we'll put that down below as well. But I think the conversation around authoring mappings, I think it's actually shifting in sense of like, you don't need to optimize for the author's efficiency anymore. You just need to optimize for review efficiency, right? Like, so if an AI or an LLM can quickly, spin out whatever, but if a human can look at it and understand what it's telling reliably, and they can maybe make modifications or fine tune that a little bit. So I think we are changing the world that we live in slightly now. Like, it's more, it should be geared more towards reviews rather than like authoring from scratch. And maybe the format for that looks like YAML. I don't know. Maybe it's just YAML that is also easy to write, but maybe it's something different. Maybe it's, you don't need to know all the nuances, and maybe you just need to be able to verify a few things, and then you'll be good to go.
I completely hear you. And if I can add to that from my AI work background, so Spacey is one of the largest open source natural language processing frameworks. And quite early on, they literally said it's a kind of continuous learning loop. We have more training data. And once humans have actually verified the output of some kind of NLP engine, that feeds back into the training data, and that way the training data grows. And it's this online learning concept where you have a human in the loop. That's what we need to design for. And I've actually tried to design those systems, and it gets quite intricate because I had difficulties wrapping it around in my head. How do I make sure it's stable? The versioning. Has a human seen this? Has one doctor seen it? Has 2 doctors seen it? what's the truth value of that single record given a Q&A test set, and then you run more into that kind of stuff. But that's in fact where the whole machine learning community is looking towards. How do we build tools to have a human in the loop?
No, that's perfectly, I think it's a very valid argument. And another point that I think I want to make here is we're seeing some of these black box mapping techniques as well. So the idea here is you have 1,000 inputs, maybe not 1,000, like maybe 10,000, a million inputs. You have a million outputs. And as a human, the actual right answer, like this maps to that, this should map to that. So you have the right answers. Now, in the middle, we are not saying this black box is non-deterministic. So we are not putting a machine learning algorithm in here. We could put a mapping, YAML file in there. But if you know that for all of these inputs, it maps it correctly to all of these outputs, does a human really need to review what's in there? Like, I don't know, for all that we care, it can be machine code, it can be assembly. But if we know that for all of these inputs and, if it walks like a duck and quacks like a duck, then can we conclude that nobody needs to review that anymore?
Yeah, but Siddharth, it's maybe you want to respond anyway, Daniel, but this to me is a non-question. But because the issue with mappings is that there is no right answer. There's always difference in the meaning between the source and the target data, and you can only accept a mapping if you can make some assumptions on how they will be used. For example, the blood pressure model in Netherlands and the international CKM blood pressure archetype. They have a different size classes for the cuff to measure the blood pressure. One goes 5 to 10, 10 to 20, 20 to 30. The other goes 0 to 10, 10 to 25. Yeah, you can understand. So this cannot be mapped. And you can map it any way you want if you know that the cuff size doesn't really matter for your use case. And you can make different mappings depending on the answer, but there is no right way to map one to the other for many, many data points, right?
But maybe again, the answer here is probably the mapping is correct based on the question and answers that you define, right? Like if you know for your use case or your context, given this, you want that, then you just feed that into the system enough, right? Like you can easily tell it that, okay, like I want the unit conversion to happen here based on the examples that you give a system. And any practitioner or like even a QA tester might be able to look at this and say that, okay, that seems to be the right mapping for this input.
But what would the mapping look like for the scenario I just described?
So if I'm to understand correctly, it's the interval is different. Yeah.
Yeah.
Like the interval of, okay. What would you call the right answer here? What would your correct?
This is my point. There is no right answer. And depending on what your query looks like in the end, you can make different mappings. But there is no right answer. That's always true. And
Got
this is
it. But
often the
then
case.
why do we need the right answer? Like, so for example, we are always using this within a context of querying and of use, right? Like we are using it in that particular context. So let's say the cost of writing the mapping goes to zero, right? Like with some sort of like black box mapping and so on. Then all you need to say is what your right answer is for that particular scenario. And you can easily get the mappings authored in like maybe a second or two, if you give it all the examples. So I'm saying like if we have the right answers and like the correct inputs and outputs for a particular scenario, then do we really need the right mapping?
Do you still need to ask to run the query if you already know the answer?
I
Like
think
what are you solving if you don't need the mapping?
Yeah, no. I mean, so let's say an incoming FHIR resource comes with like, the category of these different blood pressure, categories. We somehow need to map this to another system. Like, let's say we need to map this to another dimensional model in a data warehouse, right? So we know the kind of questions that we want to ask. We know the kind of answers that we want for the question. Now, we just need to make sure that the incoming data is always reliably mapped to some substrate that we can query on, right? And when you know what the query looks like, For example, you might want to exclude anyone below a certain value, for example, right? So
Yeah.
if you know that in advance, then all you need to do is, in this example, again, this is a very different way of looking at it, but you just need to answer that question as yes or no, right? Like, is the blood pressure mapping, blood pressure cuff size more than this, or is it less than this? And if you have a declarative language in the black box that's able to map to yes or no, and you have millions of examples saying that, then technically, again, like, you can have a human in the loop to review the actual declaration if you want, but I'm saying you don't need to if you have enough test cases. And it's able
Yeah,
to,
I think you'll never get enough test cases because each query will be unique. Of course, if you have a specific query and somebody made the mapping once, even if a machine made the mapping once, then you can reuse it. So you can train the LLM to do it. But I'm thinking that mostly each query will be different.
and that's fine. I'm just saying you just need enough examples, and we are not even asking the machine learning model to do the mapping here. We're just asking the machine
Mhm.
learning model to generate declarative code that does the mapping.
Mhm.
So you are
Yeah,
also
yeah.
sure that the code it generates is declarative. But based on the situation, and again, you can have the LLM also generate these test cases and examples.
Mhm.
You just need a human reviewing all the inputs and outputs and see if that's the right behavior.
Yeah, it's really hard for me to. I have fundamental issues with the approach because I can't oversee or understand the risk, but I also can't judge whether this concern is at all clinically relevant. If it's only in edge cases for research, probably it's not relevant at all, and it could be all automated with an LLM. It can be. I mean, you will get an answer. You just want to know whether it's a reliable answer, yes or no, right?
Mm.
So I'm really interested for Daniel's thoughts on this.
Yeah, I think I'm on the fence. So technically, yes, and yeah, it's my field of work to do, and I teach how to build AI systems. And indeed, for example, in the case of research and secondary use, the whole point is to explore stuff, and we do things with uncertainty intervals, etc. That's all fine and good. But if I go to the context of primary use, I completely feel Joost. I don't, I can't conceptualize how within the whole discussion about reliable information and data quality and data sovereignty, I'm very, very much against black boxes. And even if you say, no, it's just used as a code generative tool, I've seen over and over again that in theory, people will override the whole principle of the human in the loop. But recent research shows very people actually exercise that autonomy because we're a lazy bunch of animals. So this one quote, to have a human in loop, is far more easier said than done. A former colleague of mine used to be in aviation. He says, we had the same discussion when the autopilot was invented. How do we keep the pilot awake? And within the aviation industry, we have many protocols and securities, and you need to go up for re-examinations over and over again. We're so far removed from that within the data and AI field. Everyone can call themselves a data expert or AI expert. LinkedIn has millions of AI experts. It pisses me off to no end. I'm like, come on, guys, we need to regulate this for the high risk, for the high stakes applications,
Maybe
and
these guys
this
can make the
definitely is
mappings.
one. Sorry?
Maybe these guys can make the mappings. If there's millions of them, probably they can do it.
Well, we could hire them, yeah.
Chaos. It's excellent. So let's come back to the paper real quick. So I think just any closing remarks, any other thing I think we didn't really talk about ZIBs and the Netherlands data models and the profiles. Should we cover that a little bit?
Not necessarily, unless you think it's interesting for an international audience.
Like,
Well, yeah, I think there are some lessons to be learned, and I shared some of them in between some other points I made. But that is that previously or currently, NICTIS, the Dutch Health IT Institute, creates their own national models. and they apply them in different information standards, usually as FHIR profiles. And they have subtle differences in between implementations, between implementation guides. For example, the same field could be mandatory in the model, but optional in an implementation guide. And this leads to huge issues that actually we spent, I think, billions on health IT integrations in the Netherlands with very, very little value delivered. Probably I would even think there's a negative business case because people also waste a lot of time and effort on implementing this. So finally, we are realizing that some of the issues is that it doesn't work that way. You can't build systems if you create different constraints in different implementations because your source data is singular. The diagnosis for a patient gets recorded once by a doctor and not specifically for one implementation guide and again for another. So you need to standardize the models logically between implementation guides. And this is now what we're doing in the Netherlands. And I strongly expect that we will just adopt the CKM archetypes for specific concepts. So yeah, definitely there's a lot to learn for other countries in this approach. Also, for example, for the European health data space, where they are again making this issue where they develop specific models for specific implementation guides for the same concept. So if anybody from the EHDS world is listening to this, please consider creating a stable model as a semantic source of truth. The only realistic models available for that are the CKM ones. It will save you a lot of headaches now and later, even though I know it's politically controversial and you lose some autonomy. But yeah, Nictus has invested a lot of time, money, and energy, and it just doesn't work the way it is right now.
Yeah, and you can just go to ckm.openhr.org to check this out if you're listening. But so many of these data models probably took like, I don't know, thousands of man hours, probably more. And it will just be stupid to like reinvent all of this again for the 10th time.
Yeah, and if I can add to that, I completely and wholeheartedly support the call out from Joost. In all fairness, I did not know enough about openEHR until Joost and I crossed paths, and I love having these discussions. And from my side, I really do believe that focusing on the simple stuff first, the 80-20 rule, could we just get our act together and implement the international patient summary all over the world? And I don't care if there's another representation, it's a different representation, fine, because we have people working in different stacks. But it's one international patient summary with one semantic grounding. And already I see, oh, here's the European patient summary. Good heavens. Come on, people. I mean, that's a waste of time, right? And that's what I'm trying to figure. That was the reasoning behind those concentric circles. We can define, for example, the largest common denominator of an international patient summary, and by all means, let's make that into an international patient summary. Again, 3 years ago, that was one of the most mature FHIR profiles. Well, I was like, okay, I have a grounding, and it's imperfect, but I have a grounding. At that time, I honestly had went through all the details of the WHO ANC FHIR profile. It was nowhere near. It wasn't nowhere near. Luckily, it's now more mature, but it still has issues. And in a similar vein, I would say, we need that semantic grounding. And let's start with the IPS. I think if we really if we organize an international hackathon and saying, look, we as a community, let's build this. Let's build this. Let's map out which components do we need in the open source community to make sure that all people all over the world can start building system using this as a semantic grounding. I would love it.
Hackathon announcement.
We're doing it, Daniel. This is one of the projects from the OpenAIR and FHIR collaboration.
Okay.
Oh.
Cool.
So I really support your suggestion that the European patient summary should be compatible with the IPS, because then again you can profit from the work that OpenAIR and FHIR do
Exactly.
in this regard.
Yeah.
If you start to do something differently or even a little bit differently, then you end up with huge issues.
Yeah.
This is reminding me of, have you heard this Conway's law? I think basically they say, let's see if I can get a picture of this. So people design systems in how they are organized. So if like
Yeah.
multiple people
Yeah.
are in separate groups, then they design software that kind of resembles their organizational structure. I think Europe and the European health data space, I don't know, like I think they're sitting in some committee room somewhere deciding and planning all this. Like FHIR and OpenAIR people are at least like joining hands together and doing something together. Maybe
Yeah, but it
maybe
took us
some
decades, right? It took us 30, 40 years to realize we need to work together. And it's so frustrating that now people again are starting at zero instead of
Yeah.
learning the hard lessons we all learned.
Yeah, but yeah,
Yeah,
let's see what we can do here. Um, okay, I think let's. I think we've gone over a lot of detail. So in conclusion, Joost, the conclusion still is you need strong open source, and it also seems like another sort of conclusion is if you start with a particular standard, then it will basically spread around to all of the rest, right? Like you pick one because it's cheaper and it has more tooling. It just is the natural case that covers analytics, messaging, all of these other use cases as well. Any other like closing remarks about the paper so far?
no, just that it's been a super nice conversation, and that I'm so excited that finally the different communities are coming together, because it's such a waste of time and energy of very few people worldwide that somewhat understand this problem to be fighting each other. So I'm really happy with the three of us at least coming together and being constructive, even though there was some criticism from my part on the paper.
I mean, that's how we progress, by roasting one another publicly. So,
The criticism was well taken. I really enjoyed it. I can't wait to see the podcast published online, because I will definitely share it out to many people. Just having the time to go all the way, I think that's also just part of what I'm trying to do here. So thanks for the invite, Siddharth.
excellent, Daniel, Joost, and for all of you listening, both Daniel and Joost are independent consultants. So if you want to hire them, I'll also put a link down below. I think you've already seen their genius in the podcast. So I'll also leave a link to all the other resources. Everything that we've talked about. I think there's a bunch of different links. But yeah, I'll leave them all in the link down below. Once again, thank you for joining and like going in depth with all of the concepts with me. So hopefully we'll see you again in another episode.